Hello everyone. So today we are going to do combination sum 2. Basically this is one of the variation of combination sum 1, right? So I've also made video for that, but here is the thing is what the variation is that here the array which is being given to us, that particular array consists of some duplicate elements also. So this is the only variation which is there in this particular combination sum 2 question. Now the thing is that if this particular variation is given, then how it will affect our answer. So because of that thing only, we are required to ignore all the duplicates which are being there in our array, and we are required to ignore those duplicates just because of this fact, so that we don't get any duplicate array again as an answer. So in context of ignoring that particular thing, so that's why we would be required to modify our combination sum 1 answer in such a manner that we could ignore that. Then how we can do that? Basically, in that particular, what we were doing was we were simply taking I only, but here we would be required to take I plus 1 in our recurrence relation, and the whole thing would be as it is only. And one more thing which will be added is the part of checking that if duplicate element is there or not. If it is a repeated element, then we will simply ignore that particular element and move ahead with another element. So this is what we will be checking here in this particular solution. Now, before moving ahead with the explanation, let me first show you that how it will be done with the help of recursion tree. So let me make that recursion tree here again, just for the explanation purpose only. So if we take 1, 1, 2 and 3 as an array and target equals to 5, right? So how it would be like, we'll take for this particular one, right? And how a recurrence relation is, our recurrence relation is simply target minus our present element, right? And we'll simply increment our element. This is what we would be passing in our recurrence relation, and this is the thing due to which we will be going deeper and deeper into our that particular branch. Now, for going deep into this particular branch, now first thing is we'll do target minus sums minus I, right? So our target is 5 and our is 1. So we'll do this and push our element to our array, and we'll simply do I plus 1. After doing I plus 1, now we would be having our this one with us, right? But now we'll having this particular one with us, but we have put a condition there that if we encounter a duplicate one there. But one more thing is there in this particular question only. We were having this 1, 1 and 6, right? So we could include this particular, but we can't start with this particular as the starting element in our array, right? So we'll simply ignore that particular the next part only, but now it will simply take this particular element. So that's why our condition is something like that in here. I'll explain you that part later. So that's why we'll simply take this particular 4 minus 1 again, and now we will push this, and then we are having this 2 because it will do I plus 1 again. So now our index will be simply 0, 1, 2, 3. Now our index would be simply 2. Now I is equal to 2, so it will be simply 1, 1, 2, and then it will be simply 1, 1, 2 and 3. But one more thing was there. We were required to check for that 4 minus 1 is here, right? So even if it was done like this, so now after 4 minus 1, it will be simply 3 minus 2, right? So we pushed into our array, but now the thing was, after doing this 3 minus 2, now it comes up to 1 minus 3. It is not a valid because it comes to nectar, so we will simply ignore this particular. But it will check for other combinations also. But it is the last element only, right? So nothing is left. So in our for loop also it won't go ahead, right? So it will simply back to its parent, and its parent will check for other possible combination. Now here we are having this 3, right? And we were having this 2. Now comes the next part, that is this 3. So now it will push this 1, 1, 3, and this is here it simply gets the target equals to 0, right? So that's why this will be pushed into a result. Now it will simply go ahead back to its parent caller and will check for further calls. Now here we are having this 4 minus 2 is being left, so it will simply push 1 comma 2, right? And this 4 minus 2 will further check for further calls, so it will be encountering this 2 minus 3, which is not possible, so it won't go ahead, but it will go to its parent caller. But now as it has encountered this negative number, so it won't go ahead with further calls. So it will again go to its parent caller, and that parent caller will simply explore for more options. Now it will check for 4 minus 3. Now it will check for 1 comma 3, right? And then it will go ahead with more calls. But now there is nothing left because loop has been ended now, so it won't go ahead, right? So now no further call is left. So it will go to its parent caller. So its parent caller, now it will check that are there any duplicates there, right? So yes, there is having this duplicate branch, so it won't move ahead with this particular duplicate branch. So uh, it will simply ignore this branch and it will go to this next branch, that is 2. Now it will go for 5 minus 2, and everything would be done in the same manner only the way I was doing for this particular branch. So this is how this particular tree would be made. Now let me show you the complete tree for this particular. It will be simply like this, where this would be simply ignored, and for the 2 it will check for 3 minus 3, which makes up the possible combination, and for 3 it will check, but it won't be able to move ahead because it is moving ahead with that I plus 1 factor, and that's the reason it won't be able to make other further possible combinations, right? So that's the reason we would be having only these 2 as an answer in this particular. Now let me walk you through the code, and after that I'll explain you with the time complexity. Now this is the code which I've written for this particular question. Now how I'm writing this is like this, that this is the main function which was here. Here I have taken these 2 auxiliary vectors. One is vector and other is vector end, and then I'm sorting this particular, right? And why I'm sorting this, so that I could simply get, sorry, this is the other question, this one. Basically earlier it was for combination sum 1, now this is combination sum 2. So for this particular, what the thing is that this is that main caller which was there. Here I am taking this auxiliary array for storing our answer, then sorting my input, and then this is one more auxiliary array which I am taking, which is basically the temporary array. And this particular temporary array is something for the fact that I could store all the temporary numbers here. Then this is the function call which is being there. Now here what I'm doing is I'm passing this particular result, and this is the index, and then this is a target which was being given as input, and this local vector, and this num, basically this is that input only. And now how a particular solution is like, the first thing, this is our base case. When a target becomes 0, then we'll simply push that particular to our result vector or vector end, and this is whole of the solution which is being there. This is that particular loop which is able to find out what are the other possible options being left till now, and we could explore them. And then we are taking this particular if condition, and why we are taking this particular if condition is just because that if our present element is greater than the target, then we are not required to explore further paths, and that is the thing we are required to return from that particular recursive call we could say that particular recursive state will simply return back to its parent caller. That's why I'm writing this particular line here. And then I'm having this particular. Here what I'm doing is that if I equals to order, that is if it is the first element only, right? Then what I would be doing is, if it is first element, then I'll check that yeah, it is first element. Then this condition simply becomes true, that even if no duplicates are there in our particular array, then it will check for the first element, right? And it will move ahead with all its solution. But if it is not the first element, and if we encounter this particular thing, that now we have encountered duplicate part, right? So in that manner, it won't go further. But if no duplicate is there, then yes, it will go to this particular line. That is, it will push the num to a local vector, and then it will call the function, recursive function, where it will pass this I plus 1 and target minus nums of I. It will pass this, and everything would be like as it is. And then here is the backtracking step, so that it could explore more further options in that particular state of the recursive call. So this is how we could code this particular solution. Now comes the part that what is the time complexity for this particular question. For time complexity, this is the recursive tree I have made for explaining the time complexity. Now, here again, the depth of the tree would be at max target divided by minimum element only, right? Because if we get this particular one here, right, and if we get all the duplicate elements in the array, means if we are having all the elements as one only in this array, right? So we would be having a branch which will be having all the ones in that particular branch, right? So in that particular case, our depth would be simply equals to target divided by minimum element only. Means it is same as that only which was there in our combination sum 1. So same would be here also. And the width of this particular tree. Basically, here the width of the tree means at each node, we are not having at max n elements, because we are required to discard all those elements which are duplicates also, right? So that's why at each level, each node could have n minus I nodes at max, right? How it is possible that we are having this one, right, which is at I is equal to 0, then that's why it will be having all the branches as here the elements are 3, 6, 7, 7, right? So 7 minus 0, it will be simply equals to 7. So it will be having 7 branches here. So it is having those 7 branches. Then it is at the n minus I, and then further branches will decrease. So that's why this is how the width of the tree would be like. So that's why we can't take that particular notion which we were taking for calculating the time complexity for combination sum 1, where it was having at max n elements. So it was forming an n tree. But here that is not the case. Here it is not forming an n tree because we are discarding those branches which are duplicates. So now comes the part. So in this context of selecting subsequences, because now we are doing this particular as selecting subsequences, so we could select subsequences of size k at max, right? Our particular array could have at max k elements in it, and that k simply equals to target upon minimum element, right? So that's why a time complexity is simply k into summation of nck, because we could select at most k elements. So it is simply k into 2 raised to power n, and the space complexity is simply equals to order of k, where k is the target divided by minimum element. So this is what our time complexity would be simply like, right? And space complexity is this one. So this was all for this particular question. If you have any doubts or suggestion, you could simply comment down. And this was all, right? Thank you.